A very good morning, one and all. My name is Anil Kumar, Assistant Professor for Government First Aid College, Narragamuth. Earlier, in the last two units, we have learned about dielectrics and transients current. In the third unit, we will learn about alternating currents. The main learning objectives of this session is to understand the basic definition of alternating currents, frequency, time period, a phase difference, peak and RMS values of voltage and current. By the end of this session, you will come to know the definition of AC and the terms associated with that. Alternating currents. So now let us understand the basic definition of alternating current. Before that, let me describe about a direct current. If you look at this picture very carefully, along the x-axis you have time, along the y-axis you have current. For a given current, if the magnitude does not changes with the time, you call that to be in a current. Or if the direction of the current does not change, is also called direct current. Indeed, if the magnitudes and the direction does not changes with time, we call that to be in a direct current. However, if the magnitude of the alternating current or voltage changes continuously with time and its direction is reversed periodically, we call that to be an alternating current. As to understand better, look at this. The magnitude of the current is changing continuously with time and the direction is changing for every off cycle, and this is called as alternating current. The maximum current is represented by I naught. The basic definition of alternating current is same even for voltage. They are represented by I is equal to I naught sine omega t, or I is equal to I naught cos omega t for current. Similarly, E is equal to E naught sine omega t, or E is equal to E naught cos omega t, that is for voltage, where I and E are the instantaneous values of current and voltage respectively. That is, the magnitude of a current, voltage at any instant of time is represented by I and E. Whereas I naught and E naught is the peak value or maximum value of alternating current. Omega is angular frequency of alternating current, which is given by omega is equal to 2 pi by T, that is equal to 2 pi f, where T is time period, f is the frequency. Now let us understand the basic definition of the terms associated with alternating current. The time period. It is the time taken by the alternating current to go through one complete cycle of variation. Its SI unit is second. Frequency. It is equal to the number of cycles of variations gone through in 1 second. Its SI unit is Hertz. Just the relationship between time period and frequency is given as f is equal to 1 by t. Now, the graphical representation of alternating current is given as shown in this picture. The maximum current is a peak value, or it is represented by I naught. Now, look at this. If you observe carefully, for the positive off cycle, it is plus, in the negative off cycle is in minus. The average or mean value of the alternating current becomes 0. Now we redefine this. Instead of complete cycle, we define the average value or RMS value in terms of off cycles. Let us understand what is average value and RMS values. Sorry. Mean or average value, as we have defined, mean or average value of AC over complete cycle is 0. Now we redefine that statement. It is the mean or average value is defined as mean of instantaneous value of alternating current taken over off a cycle. It's given as mean value is equal to 2 by pi into peak value. So for alternating voltage, E average is equal to 2 pi by E naught, and I average is equal to 2 pi by I naught. Now we'll understand the phase. The phase of an alternating current represents its state of variations. It is the fraction of time period that has elapsed after the current or voltage has passed through the reference line. Root mean square value, ERMS or IRMS. It is defined as root mean square value of AC is the square root of the mean of the square of the instantaneous value taken over a complete cycle. RMS value is given by peak value to the root 2. Therefore, ERMS is equal to A naught by root 2. IRMS is equal to I naught by root 2. Lastly, let us understand the power factor. It is the it is equal to the cosine of the phase difference between the applied voltage and the current in this circuit. So the power factor is given by cos phi, which is also given as R by Z. Z is impedance. We will learn in LCR series circuit. So in this session, we learned what is alternating current, where its magnitude and direction changes continuously with time, and the terms associated with alternating currents. Let's have a quick MCQs. Question 1. Alternating currents can be produced by? Answer is dynamo. In general, in an alternating current circuit, the average value of current is 0. The frequency of AC mains in India is 50 Hz. The alternating currents can be measured by a hot wire ammeter. Alternating current cannot be measured by DC ammeter because average value of AC over complete cycle is 0. Thank you all. Hope you have enjoyed this session.